Magnificent makers, exceptional electronics enthusiasts, superheroes of CircuitPython, and people who are passionate about the Pico W. It's Prof G, and in this lesson we're going to write a small amount of code and learn how to remotely control the Raspberry Pi Pico W over the internet using a simple drag and drop web interface that you can easily create. We're going to be using MQTT and Adafruit IO in CircuitPython. It's all free, and this will set us up for our next lesson where we'll change colors, play sounds, and move a servo, all from a drag and drop web dashboard that we'll create, and we'll eventually use what we learn here to build a remote control Pico W powered robot. Let the big learning commence! So if you're here, I'll assume you have a Raspberry Pi Pico W with CircuitPython installed, and it's configured to connect to the internet over your Wi-Fi network. If you follow the installation instructions from our playlist, then you should have the libraries that you need. Reminder that my students use the free circup utility to automatically install libraries, and if you need to learn how to do that, there's also a lesson on that in the playlist. If you're new here and you need to set things up, see our playlists. There are plenty of lessons that'll get you ready. Now in this lesson, we're going to learn to create and connect a web dashboard to our Pico W. We'll send messages to the Pico W, and we'll write CircuitPython code on the Pico to receive those messages and perform a task based on the message received. Now the way we make this happen is by using a communication scheme or protocol called MQTT. MQTT stands for Message Queue Telemetry Transport. It was originally developed by IBM, but it's now open source, and it's one of the most popular ways to get devices to communicate with each other over what's called the Internet of Things. The Internet of Things, sometimes called IoT, pretty much refers to smart devices that send and receive information or that can be controlled over the internet. Now for MQTT to work, we need three pieces. A publisher that sends out messages. For us, the publisher is going to be our web browser dashboard. We'll start out by publishing a message that says on or off. A subscriber, which subscribes to or waits around for published messages so it can respond to the messages that are received. For us, the subscriber is going to be a CircuitPython program running on our Pico W that's connected to the internet. And in between the publisher and subscriber is a broker. The broker's job is to receive incoming published messages and forward the appropriate message to the subscriber that subscribed to them. So again, we create a dashboard that acts like a publisher and that will send on-off messages. There's going to be a middleman broker, that's going to be Adafruit IO, which will receive all incoming messages and will look to see who subscribed to each message. In our case, that's going to be the code running on our Pico W, and the broker will forward that message. The Python code that we write will recognize this message. In our case, it will be the on or off message, and if our code receives on, it will turn our light strip on. If it receives off, it will turn the lights off. Now, the first thing we need to do is to create a free account at Adafruit IO, which is going to act as our broker. So open a browser and head over to io.adafruit.com. Now, if you've already logged into Adafruit, your screen may look different from this. We'll catch up to where you are in a bit. But if you're not logged in and you have an Adafruit account that you might have used either for shopping or their online forums, you can use that account for Adafruit IO. So feel free to log in now if you'd like. But if you don't have an Adafruit account, you can head up here and click on Get Started for free. If you want to create a new account for Adafruit IO, you can log out first, then click on Get Started for free. Enter the standard account creation information, and click Create Account. I'm creating a new one here that's different from my shopping account just to demonstrate this. So at this point, we've created an Adafruit account, so head up to the IO tab, and now you'll see some information about Whippersnapper. This is Adafruit's no-code way to connect devices to the internet. It's very cool. Feel free to explore this if it's of interest to you. If you're interested in Whippersnapper, there's a great Learn guide on the Adafruit site written by Brent Rubel, who created Whippersnapper. Brent's a great person to follow online because he's also done lots of work with Adafruit's other IoT tools, including some of the tools that we're going to be using. But we want to write custom CircuitPython code, which will give us more flexibility and control, so we're going to ignore Whippersnapper. And instead, we're going to head up to Dashboard, which will let us create on-screen elements that can publish messages that our subscriber program will read. Now, there's a welcome dashboard already in here. You can return to check that out later on if you want, but let's click on New Dashboard to create our own dashboard. And you can give your dashboard a name. I'm going to call mine remote_control. You can do that too if you want your code to be just like the code that I'm going to write. And then I'll click on Create. Then I'll click this remote control link that was just created, and I don't have anything in my dashboard yet, but I'm going to start by clicking on the New Block button in the upper right. Now, there are lots of elements that we can create and add to our dashboard. Some are input blocks that allow us to publish values, like this toggle or on-off switch, a push button, a slider, there's a color picker down here, and there are also output blocks. These are really useful if you want to gather data from a sensor and display it. So for example, this one here shows data in a gauge format. Down here, you can present data in a line chart. For now, let's click on the toggle up here, which is a switch between two states. Next, I'm asked to select a feed that this block is going to be associated with. I've been using this for a while with Adafruit IO, so I've got a bunch of feeds in here. You probably just have the welcome feed. Publishers send information to a broker, and that's what's called a feed, a data feed, and the subscriber will subscribe to specific feeds. Now, there's a welcome feed that's here, but we're going to ignore that, and instead we're going to create our own. So let's enter a new feed name down here in this box. I'm going to enter strip_on_off. That's going to be a feed that will turn a NeoPixel light strip on or off. You can absolutely use a different name if you would like to. Just press return when you've entered the feed. The feed is created, we see it in the feed list, then click the checkbox to the left of the feed name and click the next step button in the lower right. Here we enter a block title that'll show up in the upper left-hand corner. I'm going to enter a light strip since this block will turn the light strip on or off, and I'm going to leave the button on text and off text just as shown. So in all caps on for button on text, in all caps off for button off text. These are the messages that are published to the feed when the toggle is flipped on or off. Then I'll scroll to the lower right corner and click Create Block. And look at that, we've got our first dashboard block. You can try it out if you want, but it doesn't do anything since we don't have any subscribers. But when we click on or off, we are publishing data to a feed named strip_on_off that sends the message in all caps on when the toggle is on and in all caps off when the toggle is off. Now with your Pico W plugged into your computer's USB port, launch PyCharm, and if you don't have the project sidebar open, click the folder to expose it, and we want to open the file called settings.toml. Now this should have been installed when you set up your board with CircuitPython. It's okay to recreate it if you need to, but be sure it's spelled exactly like this, all lowercase, and the end is .toml and not .py, not .txt. So what's this about? Well, settings.toml is a text file where you store things like Wi-Fi names, passwords, and API keys so that your CircuitPython code can use that data and you don't have to hard code these secrets directly into your program. If you switch Wi-Fi networks from home to school, this also gives you a single file that you can update. You don't have to worry about updating hard-coded data in every single CircuitPython program that you wrote. Now we'll give each value we want to refer to in our code a name that's referred to as a key. And then when we refer to that key in our code, CircuitPython will automatically head to this file and grab the value associated with that key. Again, as long as we use the same key name in different programs, no need to hard code the values in code.py. And if we ever need to update those values, we can just do it in the settings.toml file. Now your settings.toml file is probably blank. My students, if you have something in here that's just from a prior student in this course, you can highlight all of the data in here and delete it, and you can start from scratch too. Now you can also put comments in your settings.toml file using the hashtag character, just like in Python. And as a reminder to my students, I'm going to enter a comment that says, BC students, make sure your MAC address is approved. If you're a university student or working on a corporate campus, chances are you might also need MAC address approval. This isn't an issue for anyone working off of their personal Wi-Fi or their phone as a Wi-Fi hotspot, but if you're on a campus, check with your networking people if you need setup help. Boston College is on the worldwide EduRoam network, and that network cannot be used for devices like the Pico. If you usually use EduRoam, check with a campus network person. Now the first thing we want to do is set up the key value pairs for our Wi-Fi network and password. Now these key value pairs can be anything as long as you refer to the same key name in your code, but we'll use the standard names that Adafruit suggests in their code examples. So here to refer to the Wi-Fi network, we're going to write the key name as CircuitPy_Wi-Fi_SSID, all in uppercase. Then the equal sign, then between quotes, we'll enter the name of the Wi-Fi network that you want to connect to. You want this to be exactly as that network name appears in your Wi-Fi settings for your computer or your phone. Make sure you've got your letter case, punctuation, and spacing exactly the same, or your code won't be able to connect to your network. And for my students, they need to use the Boston College network. That's Boston College, one word, no space, with a capital B, capital C. We can't use EduRoam, the main Wi-Fi for the university campus. Our Pico won't work on that, so we use the secondary network. Next, you need a password for your Wi-Fi network, and we'll use the key name CircuitPy_Wi-Fi_password, again, all uppercase, all one word, and we'll set this equal to its pair, which is in double quotes. That's a string, and in here you should put your Wi-Fi network password. My students shouldn't have anything in here between the double quotes, no space, just an empty string, because they already have their devices approved using a MAC address. Now do be aware, if somebody has access to your Pico, they could theoretically plug it in and grab any personal data that you might have in settings.toml, so be sure your Pico is stored someplace where this isn't a worry. Now your settings.toml file is also where you can put any other information that you might want your programs to have access to without hard coding. Just create a key value pair. There's no restrictions on that. There are no required names. So we're going to create key value pairs for our Adafruit IO username and password. That's just Adafruit _AIO username, all caps. And again, we're going to refer to that key name in our code when we want to be able to get the username for this. And we're just going to set this equal to, I'll put an empty string in here, and I'll show you where we can get that in just a bit. Below this, we'll add Adafruit _AIO key, all caps, empty string. Make sure it's AIO in both of these cases, not just IO. For now, we'll set this to an empty string. We'll update it in a bit. And we're also going to add a key with the word broker, all caps, and we're going to refer to this in our code when we want to know the website that our Pico is connecting to send and receive MQTT messages. And to enter this, we'll just set this equal to the string io.adafruit.com. And then finally, we'll add port in all caps and set this equal to a number. So this is not a string, no quotes here, 1883. Now, a port is like a virtual doorway on a device connected to the internet. It allows us to send specific internet traffic in a way that a program can recognize and separate out what it needs. So these ports aren't physical connection ports. They're sort of like an extension of a software address. A device can have up to 65,535 ports. There are a bunch of standard numbers. Insecure web traffic, for example, uses port 80. Email usually uses port 25. Now, MQTT usually uses port 1883 by default, so that's what we put in here. You could change this programmatically if you needed to. We don't need to. We're going to keep with the standards. Now let me show you where we can find those values for the Adafruit IO username and key. We'll head back to the browser and we'll click this key icon in the upper right. And in here you see your username and your active key. I'm going to copy my username now, then head back to PyCharm, paste it in between the double quotes, and we'll do the same with the active key. And you see regenerate button here, which you can use if you're like me and sharing that key with the whole world in a video. If you regenerate the key, just make sure that you update your settings.toml file or you won't be able to connect to your service. So with the key copied, I'm going to return to PyCharm and paste this in between the key's double quotes. And with all the key value pairs we need in our settings.toml file set up, we're good to go. But just a quick note, now in the future you might work with additional services, maybe an internet data service that provides weather information, stock data, sports scores. These sites usually offer what are called APIs, and they have you set up an account and they have a specific API key so they can judge how often you're using the site, charge you if necessary. You can add any of those to your settings.toml code, and you can access those files in any programs that you write. But this is all we need for now, so I'm going to Command S since I'm on a Mac, Control S if you're on Windows. That should save the file. The blue unsaved indicator in PyCharm should go away, and now we can close this tab and we can open up code.py. So we're going to write code to connect our Pico over the internet with Adafruit's MQTT broker so that our code can receive messages from our web dashboard. And before we write that code, let me briefly talk you through the code we're about to write. So first, if you work through our Wi-Fi lesson, this code is familiar to you. We're importing an additional library here, though, Adafruit _mini MQTT, getting Adafruit _mini MQTT, and calling this MQTT in all caps in our code below. Now this is where we connect to Wi-Fi, and we set up something called a pool for communication over Wi-Fi. We learned about this in our prior lesson. Again, this is all repeated code, which is nice. We don't have to make any changes up here. Now down here, I set up variables to hold my Adafruit IO username and my Adafruit IO password, and I'm creating a value named strip_on_off_feed, which is my username plus /feeds/strip_on_off, which is the name of the feed that I created and associated with my toggle button when I set up my dashboard. Now I've highlighted this in a green box since this so far is the only code that you might change in the future when you write your own programs to respond to your own dashboards and do different things on a Pico W. So if you have a different feed name, you'd use that here. And in a future lesson, I'll show you how you can add more than one feed. At that point, we'll just create different values to hold the names of the different feeds. Next, we've got three main things that we need to set up when working with MQTT. So we're going to create three functions for that. Now the code that we're writing is for a subscriber, so we want to connect to our broker. So that's what we're doing in the connected function that I've defined here. This line that I've highlighted in green here subscribes specifically to the feed that we've just created. So when you write code in the future, you'd change this to a different variable name if you've got a different variable name for your feed, or you might subscribe to multiple feeds so you'd have multiple lines in here. And again, I'm going to show you how to do that in a future lesson. Now this next function that we have here, disconnected, is going to be called when we disconnect from the broker. We just print a message to the console so we know that that happened. Again, you shouldn't need to change this code in any future code that you write. And the message function down here is called when we receive a message from the broker. And you can see I've highlighted this area in green, which is specific to our program. Now what we'll do here is we'll print out the topic, which is the feed name, and the message that we receive. And we should be receiving one of two messages, either the string on in all caps, because remember, when we set up our toggle block, we had on as one of the options in the dashboard, and if we receive that, we're going to turn our strip red, or if we receive off in all caps, we're going to turn our strip black, which essentially turns all the lights off. Now, I didn't show you the code to configure the NeoPixel strip since we've already done that in a bunch of lessons. We will write that code together in Moo in just a bit. Now, this last slide of code is the code to set up the MQTT object, so that'll be standard. And once we've created that, we attach the connected, disconnected, and message functions that I just showed you on the earlier slides, and then we call connect to start our connection to the broker. And then in the while true loop, we simply call MQTT client.loop over and over again, which will repeatedly check to see if we have any new messages or if we've disconnected. And that's it. So if you want to do anything else outside of MQTT, maybe respond to a button press on a button that's connected directly to your Pico or anything like that, you could do that in the while true loop in here. But with this covered, let's write code to get our Pico responding to our dashboard toggle. And I'll start with a comment. I'm going to call this Adafruit _dashboard.py, and we'll import the libraries we need. Import board, time, NeoPixel, and then these are the ones specific to Wi-Fi. Import OS, SSL, socket pool, Wi-Fi, and then this one is specific to MQTT. Import Adafruit _mini MQTT dot Adafruit _mini MQTT, and we're going to call that, so we'll say as in all caps MQTT. So that'll be the name that we use to refer to this library in our code below. Now I have red squigglies of anger in this library name. That just means that this package has not been added to my particular PyCharm project, but we know how to fix that. Let's head up to PyCharm settings, open Python, click on interpreter, click on the plus sign to add new packages. And remember, the package names are a little bit different than the library names, but we want to say Adafruit -CircuitPython- and then the name of the package we want. I'll start up with mini, and there we go. We get the mini MQTT. Select that. Click Install Package, click Close, click OK, and the red squigglies of anger go away. Then I mentioned we're going to set up our NeoPixel strip. We're going to call this strip and set it equal to neopixel.neopixel, capital N, capital P. And in between parens, we'll pass in board dot, and I'm going to attach my NeoPixel signal pin to GP15. If you're using a different pin, make sure that you set that here, followed by comma and 30 because there are 30 NeoPixels on my NeoPixel strip. Then I'll create in all caps red, setting this equal to the tuple, so in parentheses 255, 0, 0. Then I'll create black in all caps, setting this equal to the tuple 0, 0, 0. And I'll turn off all the lights initially, so I'll set strip.fill, passing in between parens, all caps black. Then I'm going to get my Adafruit IO username and key from the settings.toml file. So I'm going to put the username in a variable that I'm going to call AIO_username, setting this equal to os.getEnv, so that's the get environment operation in the OS library. And in between parentheses, I'll pass in the string Adafruit _AIO_username. So what os.getEnv does is it's going to look inside the settings.toml file for the key that we just passed in. We passed in Adafruit _AIO_username, so it'll grab this value associated with that key and plop it back into our AIO_username variable. If we change the value in settings.toml, no problem. Every time our code runs, it references whatever's currently in settings.toml. Then down below, we'll say AIO_key, and this variable is going to be equal to os.getEnv, and in between parentheses, we'll pass in the string AIO_key in all caps. Then below this, let's set up a feed to subscribe to or listen to for messages. And just to make sure this is completely clear, I'm going to head over to my browser, and if I click on the Feeds tab, you can see any feeds you've created. You probably just have two. Now the one that I'm going to use is this one that we set up, strip_on_off. Then if I click on dashboards, the only dashboard we've set up is called remote_control, but if I click on that, let's look at the light strip toggle. So I can click this edit layout button. I can click on the little gear next to the light strip toggle and click on edit block. I can see this block has a check mark next to strip_on_off. So that's the feed that this is attached to. And if I click on next step, I can see that this button is going to send the string ON in all caps when it's on and OFF in all caps when it's off. We didn't make any changes. You can save, layout, or cancel. So now let's go back and use this in our code. I'll first create a variable called strip_on_off_feed and set that equal to my AIO_username plus the string /feeds. So all the feeds for a particular username always start with /feeds, then /strip_on_off. Remember, that's the feed that we attach to the toggle that's on our dashboard. Then below this, we'll set up functions to respond to MQTT events. And first we'll define def space, a function we're going to call connected with ed at the end. And between parentheses, we'll pass in client, comma, user data, comma, flags, comma, RC, end parens, and enter a colon. Those are all standard parameters that you're going to pass in, so you'll never change those. And when this is called, we've connected to the broker at Adafruit IO, so we'll just print out a statement that says connected to Adafruit IO, listening for topic changes in feeds I've subscribed to. And then down below, we're just going to subscribe to all changes on the feeds mentioned below, and it's only one feed we're going to monitor. So to subscribe to that, we say client.subscribe, passing in strip_on_off_feed. And it looks like PyCharm does an indent after a comment, so I'll put that indent in there. Then below this, we need to create a disconnected function with def space disconnected with ed at the end. And between parens, we'll pass in client, comma, user data, comma, RC. Make sure you close parens and have a colon at the end. This is called if we've disconnected from the broker at Adafruit IO, and if that happens, we'll just print out a statement that says disconnected from Adafruit IO. Then down below, we'll set up the function that's called whenever we receive a new message from the broker. So we'll say def space message, passing in client, comma, topic, comma, message, close with a colon. So the bulk of the code that responds to MQTT will be in here, not in while true. And first, just to make sure that we can understand what messages we're receiving, I like to print out in between parens an F string, F, and between double quotes, topic, colon, curly braces with topic in between, comma, message, colon, curly braces with message in between. Make sure you end with a double quote and close with a paren. Then if message double equals the string on in all caps, colon. Remember, that's the text that's sent over when we have a button on event when clicking on the toggle in the dashboard we just set up. And if that happens, indented below this, we'll call strip.fill, passing in between parens and all caps red. But if we didn't get on, let's outdent and we'll say elif on the next line, message double equals, and in double quotes, off in all caps, colon. We're going to set strip.fill, passing in all caps black. So that's it. That's the code that responds to the on message where we turn it red and the off message where we turn it black. Then below this is our standard connect to Wi-Fi code. I'm just going to print a string that says connecting to Wi-Fi, and then we call wifi.radio.connect, passing in os.getEnv, and in between parentheses, in all caps, it's the string CircuitPy_Wi-Fi_SSID in all caps. Reminder, that's the key for the Wi-Fi name that we had in our settings.toml file. That gets the name of our Wi-Fi network, comma, os.getEnv, and in between parentheses, we pass in the string CircuitPy_Wi-Fi_password in all caps. That logs us into Wi-Fi. Make sure you've got your closing double quote and your two closing parens. And on the next line, I'll just print out connected. Then when setting up Wi-Fi, we also need to create a socket pool. So we'll just create a variable called pool, setting this equal to socket pool, all one word, all lowercase, dot socket pool, capital S, capital P. And in parentheses, we pass in Wi-Fi.radio. And if that seems like gnarly code, well, it's just code that we repeated that we used when we originally set up Wi-Fi. You can go back and check out that lesson if you need to, but we're going to repeat that whenever we need to connect to Wi-Fi. No big deal. Then below this, we'll set up our mini MQTT client. This is our current program that subscribes or listens. And we're going to call our MQTT client just MQTT_client. And we're going to set this equal to, in all caps, MQTT. That's the name we set for the library we imported above. Within this library, we'll call .mqtt to set up the MQTT class, and then in between parentheses, and I'm just going to put these on separate lines because there are a lot of parameters to create an MQTT object, and it'll be easier to read this if I formatted this with the different parameters on separate lines rather than putting them all on one line that won't fit on screen. I'm going to set broker equal to os.getEnv, passing in between parentheses the string in all caps broker, comma, port equals os.getEnv, in between parentheses the string port in all caps, comma, username equals AIO underscore username, we defined that above, comma, password equals AIO underscore key, comma, we defined that above, socket underscore pool equals pool, comma, SSL underscore context equals SSL.create underscore default underscore context open and close parens. Now that's a gnarly bit of code, but you'll probably never change that whenever you set up an MQTT client. If you're curious about SSL, it's a standard that's used for web encryption. It just sets up some necessary data structures for longer connections to the broker. And make sure there's a close paren down below. That's quite a bit of code to set up your MQTT client, but it should be pretty much the same in any code you write in the future, so you can copy and paste that just like it was a software Lego. Then below this, I set up the callback MQTT methods that I created above, and I do this by setting up the MQTT underscore client variable I created above, followed by .on underscore connect equals connected, so that attaches it to the connected function I wrote above. Below this, MQTT underscore client .on underscore disconnect, setting this equal to disconnected. That's another function I defined above. Then MQTT underscore client dot on underscore message equals, and you guessed it, message, which is the third function we defined above. Then it's time for us to connect to the MQTT broker, which is Adafruit IO for us. So we'll just print out connecting to Adafruit IO, and the way that we do that is we call MQTT underscore client dot connect open and close paren. So that's a connect method. And then we have our while true loop. Make sure you got a capital T and you close with a colon. And we only write one line of code in here to keep checking the MQTT message queue. That's MQTT underscore client dot loop open and close parens. And if you had any other non-MQTT code in here, you would just add it below. And to jump ahead a little bit, when I ran my code, I didn't have some necessary modules in here, but I saved my code, I circed up, modules installed, and I got a network error because I'm using this on my home network instead of my school network, so I had to change my settings.toml file, but here I go, and I'm connected to Wi-Fi and connected to Adafruit IO. We're listening to topic changes, so we subscribe to our feed. Let's head over to our dashboard. Let's click that toggle, and oh, look at that, the lights turned on. Click, oh, the lights turned off. Turn them on. Turn them off! Now I'm going to click like crazy to demonstrate that it is possible to reach a throttle level in the free tier of Adafruit IO. At the time I'm recording this lesson, you're limited to being able to send 30 messages a minute. If you hit that message, you're going to see a message like this one here that says, throttle warning, data limit reached. For me, it's 17 seconds until the throttle is released. That'll change depending on when you hit the throttle. And if you click on the X, you can dismiss this little box, but unfortunately there's no countdown clock here. But if you click on and off again, do it too fast, you'll throttle again. And there are a bunch of paid tier plans at Adafruit IO. If you need more data points per minute, you can even buy buckets of extra data points per minute on a monthly basis if you want. But we don't need any of that for our simple on-off switch. Free Adafruit IO works great. Thanks, Adafruit, for such a wonderful educational resource. So now let's head back to PyCharm, and I'm going to save this as Adafruit underscore dashboard.py to our CircuitPy school folder, and make sure you close that outermost tab. And just as a note, you could make the code a little bit more robust by putting in some try except statements after, say, the Wi-Fi connect and the broker connect in case you ran into any problems. But if you ran into those errors, they would print errors to the console, so I think our examples are fine for now. This code is yours, modify it as you'd like. But Code Monster, you are now an MQTT magician. You are building web-based dashboards and using them to control your Pico W over the internet. That is some savage skill. We'll up the ante in our next lesson, where we'll learn more techniques for working with different controls, for changing colors on our LEDs, for manipulating servos, for playing sounds. We'll eventually do some online ventriloquism where we make toys speak from a distance, and we'll eventually build a robot that we can control